This video deals with descriptive statistics, and it does it in three parts. The first part looks at ways of showing the shape of data and representing it through visual patterns. The second part considers measures that summarize data in terms of their central tendencies. The third part considers measures of dispersion. An important caveat is that there seems little point these days in learning statistics by heart, and the best way to learn how to analyze data is to actually do it using software packages such as SPSS. This session will provide just a brief overview that gives a flavor of possibilities and uses of descriptive statistics. As I mentioned before, descriptive statistics provide summary information for the sample. There are two types of descriptive measures. Measures of central tendency, such as mean, median, mode, and measures of dispersion, such as range, variance, or standard deviation. Before we go into those in detail, I would like to briefly mention frequencies and graphical means of presenting data. There are several reasons why you may want to present data in the graphic format. For example, many characteristics of the distribution of data have consequences for analysis and interpretation, and these characteristics can be easily deciphered if the data is displayed in the graphic fashion. In addition, presenting the data graphically helps to communicate findings and enhances the quality of communication. I have included several examples of charts and graphs that show you some of the possibilities. Here is a pie chart, for example. Here is a bar chart that records absolute quantities, in this case expenditure. Here is another bar chart that records relative quantities, in this case percentages. Please note that your PhD dissertations are serious and formal documents. Graphs and charts can provide a really attractive summary of information, but please beware that the format that may be acceptable and attractive to managers may seem overly ornate for PhD examiners. I would advise you that you keep the graphics simple and that you develop a particular style and stick to it throughout the dissertation to make the thesis look coherent. I have included a couple of examples from my own PhD dissertations, which in my thesis can be found in the part that dealt with sample and sample characteristics. In that part, I provided summaries of the sample, and here are a few examples. This table, for example, reports general demographics concerning my respondents. I used it to show that my key informants were indeed qualified to answer questions. You will notice that I use a cross-tabulation where I have cross-tabulated the informant type, seen here, against the type of firm by manufacturing and service. I had a total of 705 respondents, of whom 247 were managing directors, 126 were export managers, and so on and so forth. Measures of central tendency provide summary information about what is typical of the sample, and there are three types of central tendency measures: mean, median, and mode. Mean provides an average for the sample, median is the value found in the very middle of the distribution, and mode is the most frequently occurring value. These values can be easily gained from SPSS analysis, and I have included here the result of such analysis copied directly from an SPSS file, which included 400 respondents, and there were no missing variables in my data set. According to the analysis, the average age of my respondent is just over 45 years. The mean is 44, meaning that if we arrange the respondents in order from the youngest to the oldest, at the 50th percentile, halfway through that queue, we will get somebody who is 44 years old. The mode is 43, meaning that of all the respondents' age groups, the group of the 43-year-olds was the largest. In addition to central tendencies, we also report measures of dispersion, which captures how much the values reported vary. One dispersion measure is range, that is the difference between the maximum value and the minimum value in the sample. Another typically reported measure is a standard deviation, which captures the average distance from the mean. Standard deviation is reported because most multivariate techniques assume data normality, and standard deviation is one indication of the normality of data. Here is another table from my thesis. This time the table summarizes information about my units of analysis, exporting firms. I have provided several indicators describing the exporters, such as number of full-time employees, company turnover, export intensity, export experience, and the number of foreign markets served. You will see that the sample sizes here vary from 612 to 694, meaning not all respondents provided all the data. I had a good range of firm sizes by the number of employees, ranging from 1 to 28,000, and the average of about 250 provides some confidence in my data, considering that this is about average for the UK. Here is another summary of descriptive statistics, this time taken from a different SPSS dataset. As you can see, in the sample of 400 respondents, the youngest was 28 years old and the oldest was 75, and we have drawn a histogram of the distribution frequencies. I will finish this video with one of the most critical considerations concerning any data analysis. There is a strict relationship between the type of data and scale you use and the type of analysis that may be carried out on the type of data you get. The best scales for any analysis are interval or ratio scales. However, if you use nominal or ordinal scale, you are very limited on the type of analysis you may be able to carry out on your data. Importantly, you cannot change it once the data is collected. That is, you cannot enrich the information by turning a nominal scale into an interval or ratio. Whenever possible, use interval or ratio scales. For example, imagine asking the respondent about their age. Your choice is just to ask them what year they were born, or present them with categories such as below 20, from 21 to 30, from 31 to 40, and 40 and over. If you do the former, ask for birth year, you have a ratio scale. If you do the latter, use intervals, you have an ordinal scale because the size of your intervals vary. The first one spans 20 years and the second and third are 10. You can always turn a ratio scale into an interval scale, but you cannot do it the other way around. If you use ordinal scales, for example, you will not be able to calculate what an average age is in your sample or what the range of your variables was. My advice is once more, whenever possible, use ratio type scales, or failing that, interval scales where the intervals are equal in size.